I like that tune. I don't know why. Yeah.
Okay. Hey. Good tunes. Good tunes. Okay, just need to turn my phone down so it doesn't ring on me by mistake.
There.
Here, I'm good. Okay.
I'm good
All right.
too.
Hey, hello everyone, and welcome to our Sunday night offering of Astronomy Outreach for August the 28th. Where is summer gone? Yay! Ooh. The Sunday night astronomy show. Okay.
Premature. Yay!
Hey. My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I'm an amateur astronomer and member of the Royal Astronomical Society of Canada, the New Brunswick chapter. Okay, right there. First of all, I'd like to welcome back our regular co-host and fellow RAS member, Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton, New Brunswick. Hey, Paul.
Hello.
Hey,
How are
evening. All right. I'd like to welcome back our other regular co-host and fellow RAS member sitting in his observatory there tonight. Hey, Mike. Mr. Mike Powell from the PFO Observatory right there here in beautiful St. John. Welcome, Mike. Good evening, everybody. Good evening, Mr. Paul Arthurs from Winnipeg, and everybody over here on Facebook as well. Mike and everybody, thanks for joining us. Lisa. Okay, on tonight's episode then of the Sunday Night Astronomy Show, it's been 50 years since humans last visited the moon. Tomorrow morning, if all goes well, we'll open a new chapter in our return and exploration of our celestial neighbor. Yay! 50 years. That chapter begins with the launch, of course, of our Artemis 1, the largest rocket ever built by NASA. Now, what is the mission? Why are we returning to the moon? And what's different about this spacecraft? Now, in tonight's discussion segment and a couple of short videos, we hope to look at some of the answers to these questions in a bit more detail. So also tonight, last week Paul brought forward an excellent presentation on how to capture an image of the Milky Way. Well, this week in part 2 of Paul's astrophoto tip of the week, he's discussing on how to take that data that you captured and turn it into a wonderful keepsake. How is data or data?
Tomato, tomato.
Potato, potato.
Perfect. And he'll also have another interesting Rosanna's fun facts piece, I'll call it. Yeah.
Fun facts.
Snippet of a segment to share.
Yeah.
Okay. Mike is adding a perspective on the upcoming Artemis mission as well with his talk, and he'll be bringing back Binal Bud with another wonderful binocular target of the week. I'll offer you a quick view of what to watch for in this week's sky. It'll be a quick view because there's just a few things that I've highlighted, and I'll also have all of your wonderful photo submissions to share. And if there's time, we'll stop right there. We're not going to have time for the other part. Okay, so this is a family-friendly interactive live broadcast. So for those of you joining us from my YouTube channel or Facebook page, we are happy to try and answer all of your questions here in real time as well. And of course, we'd like to welcome all of those who have been joining us through the local Rogers TV network. Thank you for your support. And there's Katrina Astro from Melbourne. Welcome, Katrina.
Wow.
And the waves?
Yeah.
Land down under.
Perfect. Okay, so let's get started, guys, with tonight's program and a discussion around Artemis and our return, finally, to the moon. So maybe what I'll do, then, I'll start off with a little short video. And I've got 2 videos here that I've got from NASA. Well, they sent them to me personally. Not really, but I got them. NASA's public domain. So we'll grab those.
Right?
Hmm?
It came with a spacesuit, right?
They did.
Yeah.
Yeah. Okay, let's go to one of them here.
And an escape hatch.
Escape hatch. Okay, give me a second. I'm going to get this set up properly. Let me share my screen. There. And I just need to find the right one. Okay, so there's 2 little videos here. One's called Are We Capable? Or We Are Capable, and the other one says We Are Ready. So I'm going to do the We Are Capable one first. It's about 4 minutes, 59 seconds or so long, so let's watch that first. And just give me a second. Okay.
Through Artemis, the twin sister of Apollo, we are returning to the moon. This is Orion, the only human-rated spacecraft in the world capable of deep space travel. And now, the Space Launch System, NASA's most powerful rocket since the Apollo era, stands ready. Having undergone and passed numerous tests, the time has come to complete the journey. With hardware originating from every state in the nation and from partners around the world, Artemis 1 will be the first flight test of each of these components now assembled together. These two solid rocket boosters will provide more than 75% of the thrust necessary to leave Earth. Each booster stands 17 stories tall, a full segment more powerful than the SRBs of Shuttle. Together, these boosters are capable of 7.2 million pounds of thrust and will burn for the first 2 minutes of flight. The core stage, at 212 feet, is the tallest rocket stage NASA has ever built. With the rocket's flight computer secured inside, the core stage is designed to hold 2.3 million pounds of fuel. The 196,000 gallons of liquid oxygen and the 537,000 gallons of liquid hydrogen will combine to provide 8.5 minutes of propellant to the 4 massive RS-25 engines mounted below. As proven workhorses of the shuttle fleet, each RS-25 engine has a legacy all its own. Together, these 4 engines provide 2 million pounds of thrust, and with the SRBs, are capable of pushing Orion to a speed of 17,000 miles per hour. The interim cryogenic propulsion stage is a 45-foot tall upper stage that offers Orion nearly 25,000 pounds of thrust. Performing 2 separate burns, the ICPS will first raise Orion's orbit and then, later, propel it out on a trajectory to the moon. The ICPS is powered by a single RL-10 engine that will perform these 2 burns. This storied engine has propelled robotic missions to every planet in the solar system, including Voyager 1 and Voyager 2, the first space probes to reach interstellar space. Orion's service module, provided by the European Space Agency, is the powerhouse that fuels and propels Orion in space. It stores the spacecraft's propulsion, thermal control, electrical power, and critical life support systems, such as water, oxygen, and nitrogen. Orion's crew module is the pressurized segment of the spacecraft, where future crews will live and work on journeys to the moon. Capable of accommodating 4 crew members for up to 21 days, this capsule includes state-of-the-art avionics, innovative crew systems, and the largest heat shield of its kind for entry back into the Earth's atmosphere. Positioned at the top of Orion is the Launch Abort System, designed to pull the crew to safety in the event of an emergency, on the pad or during launch. 3 solid rocket motors can activate in milliseconds, accelerating from 0 to 500 miles per hour in 2 seconds to propel Orion and crew safely away from the rocket. Now fully assembled, Artemis 1 stands at 322 feet. Artemis is no longer a series of separate parts and programs. United together, this is the first of Artemis's arrows, capable of ushering in the next chapter of human lunar exploration. Only together, this mighty system represents all that is possible, all that we are capable of when united around a stunning vision, with each component playing its part in a grander effort. We, the people of NASA and our partners, we, the people of the Artemis generation, all around this beautiful world, will bear witness to what we are capable of. Together, we are going back to the moon.
Okay,
Wow.
Yay.
that's our trip back to the moon in a nutshell. Of course, Artemis is 322 feet tall. It's the largest rocket ever built by NASA. It's let's take the two boosters, side boosters, and a big tank in the back and have the shuttle on. Let's take away the shuttle and let's make that back tank a lot larger. And then now we've got Artemis, basically. So,
Yep.
but the big test, of course, is the Orion capsule. And you know, I get a lot of people saying, why, what's the big deal? Why is it taking us so long to go back to the moon? Why do they have to spend all this time on this mission? Didn't we already go to the moon? Didn't we? Yes, we did. But when we went to the moon, we had, one hundredth of the power it takes to run my phone. And today we're going back with, well, at least two phones, right? So maybe more. But we're doing things completely different after 50 years, of course. So yes, we had to design a completely new spacecraft and a completely new heat shield. And there are 4 astronauts in this one, not 3. And we're going out past the moon, 50,000 miles and back again. So we're going to be taking the farthest man-made or human traveling, I'll say, spacecraft out past the moon than any other spacecraft before. This one's going to come within 50 miles of the moon's surface. So, but this is just a test. This one, of course, when you have a brand new rocket, we all know, I mean, with Apollo 1, when they had the fire, of course, that was the first Apollo spacecraft. And they had the fire, and 3 men died on that. So we want to be sure that we put humans in something that's safe. So let's send them out. Let's send an empty spacecraft out there, do all our testing. Is it a 3-month mission? I think that's what it is altogether. So it's going to be doing a whole lot of testing on the way to the moon and on the way back, and while it's there. And they're going to take this long elliptical orb, like say, out around it. And they're doing that because they're getting ready for when they do have the Lunar Gateway out there, which is another space station, basically, that's going to orbit the moon. You'll be launching from Earth to the space station, then from the space station down to the moon. And when it does that, it'll take an oddball path around the moon, kind of like this. So it always stays in contact with the Earth. And once they launch from Earth later on, then the Lunar Gateway is the one who'll be communicating with them on their way to the Gateway. So the Gateway comes later, and actually there's been a lot of discussion of whether or not the Gateway is even going to happen. They may do direct trips right to the moon, but the Gateway is going to be another research center, basically, for a few countries that'll be involved in it. Of course, Canada's in it too. We got Canadarm3 going on one of the missions that are going back on 2024, 2025.
Yeah.
So yeah, the date's not sure. 2024, 2025 for the first humans to make it to the moon. But we'll have the first woman and the first person of color walking on the moon's surface within 2 years. So
Canada is also supplying a lunar rover for the Artemis
right.
2 mission, I believe.
Yes. So the rovers, I mean, all the practice that we've had with the rovers on Mars is going to be integrated in back into this area. And we're going to the South Pole too this time. We're not going, in an area where we've got a big plains like they did Sea of Tranquility last time. South Pole really is an interest because of water, and we found water ice on the moon. And the idea is that we're going to go back to the moon and look deep inside some of these craters. That because of the angle of the moon and the sun, some of these craters never get have never seen sunlight in the bottom of the crater for billions of years. So we believe that there's lots of water ice down there, and we've proven that there is water ice in there. One of the missions, actually, I think the LRO actually flew through. It dropped something down into one of the craters, and the stuff came up, and it kind of flew through it, and it smelled it basically, and said, okay, there's water ice on the moon. So there is water on the moon. We've got to get it. It's underneath the surface, and we need that to help produce propellant to get home. Of course, it's gallon a day, 4 gallons a day per person, I think, that they require for water. So all these things are going to be required, but it's mostly about the water. But it's getting us there now after 50 years, and there are ESA's involved in it, NASA's involved in it, CSA's involved in it. Like, we've got lots of big agencies across the world that are getting involved in this our return back to the moon. I'm so excited to know that we're returning back to the moon. I mean, I remember watching the original. I know it's not possible that I could be that old, I know, but I remember watching Neil Armstrong make his first steps, and it was incredible. And I watched when they left the moon for the last time in '72, and you think, wow, it's been that long since we've been there to visit it. And we spent all this time in low Earth orbit. Now, in low Earth orbit, we spend a lot of time just discovering stuff and learning how to grow vegetables and learning about radiation and the effects of space flight on humans, like our eyeballs change shape and that kind of stuff. Medically, how do we keep calcium moving in our bones, how we keep our muscles strong. So we have learned a lot with the space age, but we spent the last 40 years in low Earth orbit. So we haven't really progressed. I mean, we haven't gone farther ahead in our exploration. So we started out with the Apollo.
Yeah, having said that, though, a lot of what progression is happening now is not even NASA. NASA's doing a lot of it, but their foresight is that SpaceX will be doing a lot of stuff that NASA is going to actually be contracting, because they're even talking about SpaceX being the ones to have the landing system for the rockets.
Yes.
I mean, NASA still has a plan to try to do it, but because SpaceX is so innovative, and if they don't, and they are reliable, I mean, they're becoming an extremely reliable source of doing what they do, that they're going to start relying a lot on them for a lot of these connecting missions.
Exactly. Yeah.
So that's kind of what they're foreseeing in the next little bit, because they were thinking also that they're going to be the ones that are going to be taking these different rockets and bigger ones that'll house more people and things up there. So there's so much stuff in the build stage right now and in testing stages that's not only from NASA, but from, or I shouldn't say only from countries, but from private sector.
Right.
Well,
I mean, it was the same as SpaceX has basically been called the workhorse of the ISS now. Like most of the missions that go to the ISS that take supplies up and bring experiments back are coming from SpaceX. And SpaceX has the contract to put the astronauts on the moon. So that's supposed to be with a Starship type of spacecraft, right? That'll land straight up like that. They're still in development, of course, with Starship, but I know that they'll, with them it's test, fail, fix it, repeat. And they've done that so much and so well that now you see the launches of the Starlinks and another launch, landing it on a drone in the ocean. No, not a big deal. So that's what it's become. But NASA is talking about contracting a whole lot more of that because they want to keep to the science, NASA side, right? They want the moon base built. So who's going to build us the moon base? Because we want to get our astronauts there to do some science. And this time we're going back for science. Like, yes, the first time around it was more of a discovery kind of thing. We beat the Russians to the moon. That was the whole idea. And after by Apollo 12, it kind of rose like that and fell off again. Of course, Apollo 13 brought the interest back again. But when we're getting to 14 and 15, they were like, who can remember the astronauts that were on the moon in 14 or 15? So by the time we got to 17, I mean, Harrison Schmitt was the first geologist that actually went to the moon. He was on Apollo 17, the last mission. So they hadn't even taken a geologist to the moon before that final one. So we're getting back to the science side, and all this stuff is going to be like NASA's saying, we want a moon base, we want it built, we want all the supplies there long before we send the humans there, which makes sense. Why risk anybody's life? If you can help it. So let's get the rovers there. And there's a whole pile of robotic stuff coming up before we actually get to the moon as well. Not just that they're going to survey where the water is and the exact spot where they're going to land, but rovers that are going to be on the surface helping set up stuff and delivering products to the moon and getting everything all set before we send the humans. And we waited 50 years, was another couple of years to have everything in place, for the right way, right? So I think they're doing it right there. It's just that it's a very expensive endeavor. Like this rocket here, this Artemis, I mean, I don't know, $2 billion, $3 billion, something like that. And it's disposable. Like, the solid rocket boosters they'll get used over again, I'm sure. But the rest of the spacecraft, I think, is just dropped in the ocean, including the RS-35 engines that they used on the space shuttles. That's what they recycled those motors and put them on, or engines, and put them on this big one. So
yeah, they're having discussions a lot about that too, about the environmental impact that not only on Earth but out in space, because the more that you start, like right now we're sending up, I don't know, 100 people a year into orbit. You know, by a couple 3 years we'll be putting 1,000 people up, and then more and more and more. So you can just imagine a lot of the impact, environmental impact that's going to have. So.
And I think that's where it's going to lean NASA towards SpaceX to say, okay, well, you take over that part of the role because you're bringing 80% of your spacecraft back to the planet again. So there'll still be some that'll be left, but it can't be avoided. But I mean, they're even capturing the fairings now. When they break open the fairings, when the satellites take off, they bring those two halves down and catch those as well. So they're doing really well that way, recycling, and that's what's keeping their cost low, and that's what's keeping them on the forefront, because people will go ahead and register them for a satellite launch because they can do it cheaper than anybody else. But it's going to be interesting. Like this is just the start. Tomorrow morning, of course. So I mean, it's tomorrow morning is the first of Artemis launch. And it's going to be exciting to watch. It's going to be exciting to watch over the next little while they test this spacecraft and see how it does perform. I'm sure all over the world agencies are going to watch this spacecraft and see what happens. So I think it's a fantastic way to get back at the moon. It's our celestial neighbor. We got to learn how to live on the moon before we move to Mars. Yeah. We're talking an 8-month trip to Mars, at least a couple of years out there, because you're going to catch up to Mars, land on Mars. Earth's going to go by it, and then you have to wait until Earth gets all the way past Mars again before you launch and catch up to us again. So you're looking at a couple of years at least on Mars, and 8 months there, 8 months back. So you're spending a lot of time out there, right? So we got to make sure that our humans are safe doing this kind of thing. So I think it's a wonderful mission. I support it 100%. I know it's a big cost, but there are going to be a lot of things that come down the pipe, like they always do when you have hundreds of agencies around the world working on one particular project, like Velcro. Like Velcro came from Apollo, so lots of other medical advances as well. So yeah, okay. Anything else, guys? Thoughts?
Mike's got some stuff.
Well, I got a little slide.
Yeah, okay.
Quick thing. Sort of some you may or may not know about Artemis. If I guess it's this one. Hopefully it's this one. We should see what the Artemis rocket looks like.
Yep.
Yes, we're going back to the moon. This is Artemis 1. So just a couple of things here. The Space Launch System is the most powerful rocket in the world, which Chris's video already said. The SLS produces 8.8 million pounds of thrust at launch. That's 1.3 million pounds more than the Saturn V. That's hard to fathom.
Wouldn't it be nice to be standing there listening to that, though?
Oh, yeah, that'll make the ground rumble. And the SLS is heavy. Once fully loaded, the combined weight of the SLS and Orion spacecraft is a whopping 5.75 million pounds, or roughly 2,875 tons. She's a heavy piece of equipment. There's no question about that. Also, it's very tall. At 322 feet, the SLS is taller than the space shuttle, by 138 feet. However, it's the second tallest rocket flown by NASA. The top honor still goes to the Saturn V of the Apollo program at 363 feet. Yay, Apollo. And here's the one that gets me. It's fast. After launch, the SLS and Orion spacecraft will reach speeds of 22,670 miles an hour. That's 29 times the speed of sound. That sucker's going to be moving when she's leaving.
Wow.
Yeah.
And it can lift some serious weight. The SLS will be able to lift, try 27 tons. That's 5 more tons than the space shuttle could lift. That's a lot of weight when it comes to putting stuff into space, 5 tons. And it'll go very far. Like Chris said, the Artemis will be the furthest any exploration spacecraft has ever flown since Apollo, roughly 280,000 miles from Earth. And then again, did we say fast? After completing the mission around the moon, the Orion spacecraft will return to Earth faster and hotter than any other spacecraft before. On its return, Orion will reach speeds of 25,000 miles an hour and produce temperatures of 5,000 degrees. Wow. Boy, she's going to be one heck of a bullet coming into the atmosphere.
Wow.
And from start to finish, after splashdown, the Orion spacecraft will have flown almost 1.3 million miles. That's about 53 times around the Earth in this one mission. So that's pretty cool. And again, tomorrow is launch day. So the launch of the Artemis is scheduled for August 29th. And the launch window will be between 8:33 a.m. and 10:33 a.m. And guess what? They said there's no astronauts on board. Yes, there is.
Yeah.
Scott is going into space on the Artemis 1. So they will have an astronaut on board.
That's pretty bad.
Yeah, that's just a few facts that I wanted to pass on about that. So
Awesome. Thanks, Mike.
Oh my gosh. He says it with a sheepy grin.
come on.
Yeah, sheep. Oh, wow. Okay, keep going. I'm out. I can't match him at all.
That's pretty bad.
He's the king. The puns. The king of the puns.
Oh my.
Yeah, somebody. People were asking about the reverberations. Like apparently when the Saturn V launched, the first one, I guess Apollo 7 would have been. The guys were sitting there in the operation center, and they said they could feel it in their chest, like their chest just bouncing because this is much more powerful again. So it would be incredible there. Somebody said setting off car alarms. I'm sure they would be probably from miles away.
I think too. I read somewhere that it's dumping twice the amount of water on the launch pad than the Apollos did to try to muffle or baffle that sound.
Right, and they have the big flame deflectors too set up
Yeah.
there, I guess. So yeah. Yeah, it's gonna be something to watch, and they're saying it's an 80% go right now for weather-wise, so looking good. Now, anybody who'd like to join me, I'm going to be watching it live here on NASA's live feed. I'll be logged in probably around 8:30 or so in the morning, or maybe it'll be 9 o'clock. I guess launch is 10:30 for our time, right? So I'll be logged in anyway in the morning. So if you want to come on and join and share the launch with me, that'd be great. I'll be feeding it out to Facebook and YouTube from NASA's live stream. So,
right on.
Now we get time for the second video. It's 8:25.
Well, we were going to show the picture there.
Oh yeah, right.
Yeah. So this picture I'm going to share with you is it's a collaboration of two guys over the course of 2 years, and they got the inspiration from what's going to happen tomorrow. So I'm just going to share my screen and show you what it is that we're talking about. There it is there.
And it's going to be too cool.
So ridiculously detailed, the new image of the moon is a masterpiece of space photography. So this image that you're looking at here, I'll just kind of read it because it's easier to get the information from there. So time to upgrade your wallpapers, people. 2 astrophotographers have just dropped what they call the most ridiculously detailed picture of the moon, the result of a painstaking neck-craning effort, roughly 2 years and over 200,000 frames in the making. Now, for millennia, humans have looked up and seen the same silver orb transversing the night sky, but never quite like this. A space photography enthusiast, Andrew McCarthy, says of his collaboration with planetary scientist Connor Mathern, behold this stunning image. Now, when you look at the image, you're thinking it's not traditionally what we see based on the colors that are there, but let me get into that. So while you feast on this 174 megapixel beauty, you can see the moon tinged red and gunmetal blue, illuminated on the right-hand side as it faces Earth. Let me just roll this back so you can see what I'm talking about. Let's see if I can make this longer. There we go. Where are we at? Through the colors of his false, they're technically the moon's true hues, only that our eyes are not sensitive enough to see them. And so McCarthy gave the image a saturation boost to bring out the colors in all their glory. So McCarthy's specialty is actually detailed photographs, taking tens of thousands of photos to capture every nook, cranny, and crater on the lunar surface. And Mathern, a planetary scientist and deep sky photographer himself, shooting from Louisiana, is the color buff when it comes to this particular image. So as far as how it was made, the masterpiece consists of more than 200,000 images, all taken over the course of a single evening and stacked together. The whole thing is assembled like a mosaic, and each tile is made up of thousands of photos, McCarthy told NPR. Simply what we must have been a lengthy editing process. And the pair have certainly outdone themselves and given NASA's James Webb Telescope some run for its money. Anyway, the article is a little bit longer than that, but you can look it up. It's just called Ridiculously Detailed. And this was actually sent to us from Rosanna, and because she thought it was just an absolutely amazing thing. And the fact that they that the inspiration for them to do this is tied into the to the launch tomorrow. So
Awesome.
That's very, very cool. So go online, have a look, and you will be absolutely mesmerized by this thing.
It's unbelievable that there's that much color in the moon. You never really think about it.
Oh,
yeah. Mm.
Yeah.
It's so bright you can never tell.
No, that's it.
Awesome. Thank you, Rosanna, for that.
Yes.
It's awesome.
Awesome. Okay. I'll quickly go through that second. Are we got time for the second video, or do we bother?
Got all the time you want.
Yeah.
Okay. Okay. All right. Let's go with the second video then. It's another video from NASA as well. I'm going to share my screen. So that was, last one was We Are Capable, and this one is called We Are Ready. So it's another 5-minute video. It does share a lot of what's going to happen, I guess. So kind of why I wanted to present it. Okay.
Artemis stands ready. Ready to turn dreams into reality. Ready to return humanity to the moon and take us further than ever before. The culmination of inspiration and innovation, of Herculean efforts and steadfast collaboration, Artemis 1 is ready for departure. And the Artemis generation is about to leave its mark.
What will be a journey of more than 500,000 miles to the moon and back starts right here at Launch Complex 39 Bravo. Although this first flight will not carry a crew, it will test every system in the deep depths of space to prepare the way for future crewed missions.
When the final go is given and the teams at Kennedy Space Center release this rocket, Artemis will roar to life and we will witness the beginning of a tightly choreographed mission.
All engine 1, 2, 1, and liftoff.
The first 2.5 minutes lift Artemis off Earth and build momentum. It's another 6 minutes of pressing uphill, accelerating to orbit. This is followed by a push from the second stage to raise Orion higher.
And once all the systems are cleared to continue, the second stage will fire again and push Orion beyond the bounds of Earth. At this point, we're going to the moon. It'll take several days to reach our destination, but as we sprint across the void, many new procedures and systems will be tested and proven.
240,000 miles later, Orion will enter an oval-shaped orbit around the moon, one that will take Orion to about 60 miles above the lunar surface and then out to 40,000 miles beyond the moon. This is a distance farther than any human-rated spacecraft has ever gone before.
As momentous as reaching the moon will be, returning to Earth is just as significant and challenging. Every observation we make, every lesson we learn on this journey prepares the way for humans to safely venture out and return home. And so on its final lap around the moon, Orion will ignite its main engine, push out of lunar orbit, and begin the long trek home.
This is a spacecraft built for the harsh conditions of deep space, as well as the intensity of returning home. Nearing Earth, Orion separates from the main power and propulsion systems of the European Service Module and prepares for the final sequence of events. Entering Earth's atmosphere at 24,500 miles per hour, the heat shield endures the fury of re-entry. The air around Orion reaches temperatures half as hot as the sun, but also slows Orion considerably. Until finally, parachutes can deploy, allowing Orion to gently dip into the Pacific Ocean.
to the moon and safely home again. This is the journey of Artemis 1, and it will set the precedent for all that follows. United with partners around the world, this is the challenge we choose. To meet hand in hand, step by step, lighting the way from the Earth to the moon to Mars and beyond. We are ready.
There we go.
Wow.
And the way they do that, just like a just like a movie trailer, right?
Yeah, exactly.
They make it pretty interesting. So yeah, it's it'll be an amazing mission. Let's wish them luck tomorrow. And I'll be tuned in tomorrow morning. So if you folks want to join on, please feel free to come on along with me on the journey. Okay. Not much else I can add about that. Katrina says, "Come on, NASA, get metric." Absolutely. True enough, Katrina. Yeah, it should be metric by now, you'd think. Probably the scientists mostly are, but.
Well, isn't Europe going back to the Imperial?
Are they? Oh,
yeah.
Really?
Wow.
Wow.
Or England is, I think.
Okay, let's go from there then maybe to, how about we start with the Bino Bud tonight?
We got a Bino Bud. Alrighty. Oh, Binocular Target of the Week this week by Bino Bud is the Triangulum Galaxy.
He's pretty hard to drive, those guys.
That's where they got him to pose like a piece of pizza. Yeah. Triangulum Galaxy is a spiral galaxy 2.73 million light years from Earth in the constellation of All Triangulum. It is cataloged as Messier 33 or NGC 598. Triangulum Galaxy is the third largest member of our local group of galaxies behind Andromeda and the Milky Way, and is one of the most distant permanent objects that can be seen naked eye, believe it or not. But you've got to be in real dark skies to do that.
Oh, yeah.
So, I was going to say, how do I find it in the sky? Well, this is a large overview. Let me see if I can get a little closer. But if you go out at 10 o'clock and orient yourself 270 degrees to the west, it should be right in here below Perseus. Anyway, let me go again. So here's Andromeda. We all know how to find Andromeda. You come down from the great square of Pegasus, 1, 2 stars, and then up 1, 2 stars. Well, if you went the opposite direction, but the same distance, you would find the Triangulum Galaxy. How's that? Good. So, that's one way of doing it. Find your way over to Andromeda and just go backwards, 1, 2 stars, and then the same distance, say 1, 2 stars. What will you see? Well, this is what it looks like, but this is not what you're going to see in a pair of binoculars. And Paul, you're going to have to photograph this one now because I'd love to see the colors that you get in that. That'll be amazing. Because I know you've got a photo you're going to show there later that's just awesome, man, of something else. 10 by 50 binoculars. There's what it looks like. So it is large. We thought Andromeda was a pretty big size at 10 by 50s. Well, guess what? The Triangulum stands out there too. It's a big galaxy to see. Compared to the full moon, got to be at least 2 full moons across. So it's a good size, fairly easy target to find. If you can find Andromeda, I'm sure you can step through and find the Triangulum Galaxy. And they also had Shaun the Sheep testing you into outer space. So there he is in his weightless atmosphere.
Yes, sir. I bet he'll have some stories to tell.
And that's Binocular Target of the Week by Bino Bud.
Awesome. Thanks, Mike. Another great one. Another easy one to get, though, as well. Like you said, 2 stars out, 2 stars up from Pegasus to get to Andromeda, and same
go
distance
the other way.
Cool.
Yep.
Like it. Okay.
Now I'm going to have to go buy myself a Shaun the Sheep astronaut toy because I don't have one. I got to get one.
Well,
So when he goes to sleep, does he count humans?
Maybe so, yeah.
Wow. The show's going downhill. Sorry, guys.
That's bad.
That's a bad one. Okay.
Oh,
We'll take it anyway. What the heck? Yeah.
I have
Okay.
to.
Astrophotography tip of the week. Paul, what do you got?
All right. Well, we're going to finish up our segment from last week. And last week we talked about taking a Milky Way picture. And actually, and I didn't mention this, but the Milky Way picture that was taken was a single frame. So this is something you can do. You don't need to go out and spend a bunch of money and stuff. But dark skies are very, very important to be able to be able to get a one-shot shot like this. And so this week, what we're going to do, we're going to take that single frame, which is just a dark image, and we're going to turn it into something, hopefully, that you might be happy with and might want to share with your friends. So let me share my screen, and I'm going to show you that. Whoops, show you that dark image there first. Okay, so first of all, I'm going to do this relatively quickly because this is quite a simple thing to do. If you have Photoshop, which most people have or have access to, this is quite an easy thing to do. So I made a couple of adjustments on this picture before I started, and they're simple adjustments. And let me see if I can go backwards and do this. Yeah, there's a free transform I did, and there's a spot healing I did, and there was, I'm just going to take it back to there. Because when you take your picture out of your camera, the first thing you're going to probably notice, actually, you know what? I'm going to take it right back because it'll only take a second to go through each one of these. There. Now I'm back to what came right out of the camera, which is what you're going to have. So I should be showing you this. So when you take it and you're using a wide angle lens, lots of times with those wide angle lenses, there's aberrations. Even though your image is, you try to make it as straight as you can, and you try to get that, that horizon as straight as you can, depending on where you put that horizon, no matter how straight or level your tripod is, the lens itself is going to bend that picture a bit. So you need to know how to straighten that out so it doesn't look like a distorted lens. So the very first thing I always do with my images is, if I'm using Photoshop, you just go up there where it says filter, and then you simply click on where it says lens correction. And then you're going to get this little screen come up. When this lens correction comes up, it just wants you to put in your information. For example, what camera maker you're using and what lens you use. So in my case, I've already got mine already as a profile. But if you don't, this is how you do it. So you just type in the brand that you have, or you just click on the down arrow, select the brand that you have. In my case, it's Canon. The camera model, and you say, same thing, just click the down arrow, and it's an R6. That's what I use for this shot. And then the lens model, and I used a 14 to 24 millimeter f2.8. So EF24 to, or 14 to 24, where you are. 14 to 24, it's right here in front of me. I just didn't see it. There it is right there. And you just click on that and watch the picture when I click on it. You'll see that there's a movement in the picture. So what this has done, this is actually corrected for the lens's spherical aberrations. Now, it still didn't correct it completely because 14 millimeters is an extremely wide angle lens. So there's a really cool trick I'm going to show you that a lot of people aren't aware of. And it is called, you go up to your edit button. But before you do that, make sure that your image over here, every time you put an image up, there's a little lock on it. Make sure that lock is off. You just click on it, and then it unlocks the image. You go over here where it says edit. You go down to where it says transform, and go down to where it says distort. And what this will allow me to do is I can grab this picture at any point of it. And if this lodge, this is, by the way, Mount Carlton again, for those who didn't see last week. This is the new lodge they built on the far lake in Mount Carlton. But this lodge, even though we did the aberrations and stuff, it's still sitting kind of funky. It doesn't look straight to me. So you can just go into that little transform distort, take this little corner down here with your mouse, and you can pull it down so that it's nice and straight. Even though you can straighten it out with a rule tool, or you can still straighten the picture out with crop, it still doesn't straighten out that bend in the image. And this is what the distort does. This will allow you to take that out. Once you've got that done, you just simply click on the OK, the check button, and now we have a nice image. Our lodge is where it should be. Things are nice and even. If you want to check it for evenness, you can just go to this little 3-dot tool down here, which is the ruler tool. Find the spot on the lake where your mountain joins the water, and just draw it right straight across to the other side. and you can set it so that it's nice and straight, like so. And then just go up here and click straighten layer, and it will straighten the layer out for you. So there, that's perfectly straight. If you have these aberrations, there's a couple of ways to get rid of them. You can use your healing tool. You just click on it, and then you can just kind of run the healing tool. Whoops, sorry, my mouse is slipping on me. But anyway, it'll actually clean that stuff up, but it does take data out. So the easiest way to do it on a big picture like this is just go ahead and crop it out. So just crop out the areas that are showing white, because this image is so wide, you're not going to lose any crucial data to do this. And just go ahead and do that. Once you've got it cropped, just make sure that your content aware is on, because sometimes if you miss a spot, the content aware will actually fill it in, which is kind of cool. But anyway, just click on the old thing, and now we've got an image that is all straightened out. The aberrations are taken care of, and now we're ready to actually process it. So the very thing I'm going to use in here, instead of going into Lightroom or all this other stuff, I wanted to use one filter on this to do all the processing. And the filter here, you just go to filter up above where all your tools are. Go to filter and then go to camera raw. It's going to open up into what I call Lightroom Light. It's got all the things you're going to need to make the adjustments on this picture. Now, the first thing you're going to notice on this picture is it's really dark on the bottom, right? So it's really not doing anything. I don't have any sense of what's below that skyline. So what I'm going to do is I'm going to just use very basic tools here. If you look at the side, there is a little, what looks like a Band-Aid, which is a healing tool. Just below that, this is where all of our little gradient tools are that we can actually do masks with. Really simple. You click on it, and then you decide, okay, what do I want? So I wanted to, I want a brush. So just click on brush, and then I'm going to add the brush. That's it. Now I'm ready to go. I got my brush. I can make it as big or as small as I want. And you can see that if I roll my mouse, the little wheel on my mouse forward, the brush gets bigger, or if I drag it towards me, the mouse or the cursor gets smaller. But I can see where my lake is here. So what I'm going to do here, I can just simply paint that little spot there. And all I'm doing is I'm creating an area that I'm going to be working on. Now, typically I would have done this with a gradient tool, which would give me a straighter line, but I just want to kind of get through this a little quicker for you, but you can use this tool. Once you've chose the mask, then as soon as you go down to your tools right here, then as soon as you click on any one of those tools, then that mask should disappear. And then as you make the adjustment, yeah, there it is. Okay. And it's very, very slight adjustment on this one. I'm going to bring up shadows. Okay, you know what it is my opacity on my brush was not strong enough. So what I'm going to do is I'm going to just go ahead.
I was going to say that, but
yeah, I'm going to go ahead and reset that, and I'm going to go to a linear gradient instead. This one here is I'm going to add the linear gradient, and this is what I'm going to do with this one there. So that's a nice straight line. It's the same tool, except it's just a different way to apply it. So you just pull that little linear gradient up, make that line, and whatever happens in here, this is where you're going to adjust. With these, because it's such a gradual thing, you want to pull it a little longer than where the line is, because it fades out. It's a very gradual thing, so that you don't have these harsh lines. And then all I'm going to do here now is just add a little there. So you can start to see the beach. I want to add the foreground of the beach in here. A little bit of shadow on that. There we go. All I want to do is give a sense of that beach that's there. That's it. So once I've got that done, I just simply go up here to my regular tools, click it, that adjustment's made. Now I just want to make another adjustment. I want to take and make this lodge not so dominant. So here, I'm going to again click on my tool, and every time I go back to the same tool, and I want to brush this one this time. So I'm going to click mask, create a new mask. I want to brush. And I'm going to hit add the brush. And that's it. And then just add the brush. There's your brush. I'm going to make it small, and I'm just going to give this a much stronger brush than I did last time. Now all I want to do is I want to take that down. So I want to drop the highlights on that. So I'm just going to go over to my highlights and just simply drop it back. And now you can see how that lodge is now not so dominant, because I want the Milky Way to be dominant, not the Lodge. I don't want that distraction there, but I want the target there. So that looks good to me. So I'm fine. So again, once I'm done that, same thing. And you're going to notice as I'm making these adjustments, it's the same thing over and over. Just I'm selecting different areas in the picture. Click my regular tool. So now I've got 2 adjustments made, as you can see, and they're starting to build layers, right? There's mask number 1, which was this part, mask number 2, which is this. Okay, so the next thing I want to do is I want to bring my Milky Way out. I'm going to go back to another brush. So I'm going to hit brush and create new mask, add brush, just like I did before. And this time, I'm going to paint the Milky Way, just the Milky Way, because this is what I want to bring out, right? So again, I'm just going to do this quickly. Once I've got that, now all I want to do is raise my exposure just a little bit. And look how the Milky Way is just starting to pop. But only the Milky Way, not everything else in the picture.
That's cool.
Okay, so that's it. So once I got my Milky Way to where I like it, if I want a little more color to it, well, I'll just go down to my, because you can access any one of these tools while you're doing this. So I'm just going to go down to my saturation, and I'm just going to saturate a little bit. Just give it a little bit more color. And maybe I want to warm it up a little bit, so I can just kind of turn it a little more to the yellow side, which is warmer. Or if I want to cool it, go to the bluer side, and I can cool it down. But in any event, you find what you like in your Milky Way. Once you've got that done, I can say, okay, click the same old tool. Now I want to bring out the water in the lake, because it's really too dark for me, right? So what we're going to do with this one is, again, we're going to go back and click on our gradient tool. We're going to create a new mask. We're going to add a linear or a radial gradient rather this time. And when I click on this, it's going to give me this little circle. So it's just another form of what we've been doing, except now I'm just going to stretch it out. And I'm going to stretch it out. And I'm just going to angle it a little bit. And I just want to bring out the water more than anything else in this particular shot. I can do this with a number of tools, but anyway. So let's just, once we've got that in place, go ahead to your exposure button. And we're just going to bring that up just a little bit. And as I bring the water surface up, look what happens. Also, the reflection of the Milky Way is now popping out in the water. And so is the stars and all the glorious color that's in there. Once I've got that done, I simply click that same button on the top. I'm almost done. So what else can I do to this photograph? Well, I can do a few more things. But if I was happy with this, and I'm just going to say, okay, I can see my Milky Way, I can see the lake, I can see the beach, the lodge isn't a major distraction, the stars look fantastic. You know what? I'm done. Okay. Then all you do is press OK, and it's going to throw you right back into Photoshop with all of your adjustments. And there it is. So once you've got that done, all you have to do now is just, okay, you know what? I'm excited. I got my Milky Way picture. I want to share it with my friends. So before you share it with your friends, remember we're shooting in RAW, and it's a very big file. You're not going to be able to share it on the internet until you size it down so that it will go on the internet comfortably. So how do you do that? Very simple. You go up to the top of the tools again, where everything else is, and you go to click on Image, go to Mode, and go down and change that from a 16-bit file to an 8-bit. So now we've reduced the size of this file immensely. The next thing we're going to do, if we want to, for artistic reasons, I might want to put a little frame around that because I think it's kind of cool. So we go to Edit, we go to Stroke, and then I'm going to put a white frame around it just to show you that, or a gray frame rather, just to show you we put a frame around it. I'm going to OK that because you click on the color, and there's the color palette right there, and simply hit OK. Now I've got my color gray. I'm happy with that. I want my frame to be about 10 pixels. So you can have a really thick frame or a really thin frame, whatever you want, or outline. I'm okay with 10 pixels. I'm going to hit OK. So there. Now I have my frame around my image. If I want, I can go down to here into the text, and I can actually sign it if I want to. I won't right now because there's really no need. When you do click that, what that does, that creates a layer for you. So if you don't want to see it, just turn off the layer. It disappears. Once I've got that done, then the final thing I need to do is to convert it into a file that the internet likes. So I'm going to go File. I'm going to go down to Save As. And then when I'm in here, I'm going to throw it on my desktop, or I'm going to throw it in a file, wherever I happen to want to put it. And I want to change this. I want to save it as, okay, just a sec, sorry. Hit Save a Copy. There we go. And that'll give me more choices. I want to save this as a PNG. Why a PNG and not a JPEG? Because a PNG will keep the quality and integrity of your picture much better on the internet than going to JPEG. You go to JPEG, throw it on the Facebook, it's just picture looks like terrible. You can't blow it up. It looks terrible. So you go to PNG and simply hit Save and OK, and that's it. You're done. You just go ahead and find your picture on your wherever your picture is on your computer, and go to Facebook. Everybody knows how to share pictures on Facebook. I don't have to show you that. And that's it. So we went from that really dark, lifeless picture and just made a few adjustments in what we call Camera Raw. And now that Milky Way just came to life. Now you got a picture that you can be proud to show your friends.
That's awesome, Paul. Wow, that's amazing. Yeah, I don't think I've ever used the brush tool. Now I know about it.
Yeah, well, and once you just, if you're not familiar with it, go throw a picture on it. Doesn't matter what it is. Click on that brush tool and just start playing around. You'll get a feel of it really, because it's really intuitive. Once you start moving stuff, it's just like, oh, that's what it, oh, okay.
Oh, that's
right?
awesome. Yeah.
And then once you do that, then you can take a picture, any kind of picture, whether it be a space picture, family picture, and you can go anywhere in that picture and make all these selected adjustments. And, there's a million other ways you can do it. When Kathy was on, she showed a bunch of ways you can do it with in layers. But I found this to be for somebody who's just starting out and they're not familiar with layers, and because layers can be very confusing. And it was for me for the longest time. In fact, I went to Kathy. I said, Kathy, straighten me out on layers. But when I work with Camera Raw, I get the same thing, but it's all contained in one filter, and I can do everything I want to do in there. Pretty much what I can do in the other softwares, except for some of the larger things like sorting pictures and all that. But this is just kind of put this together. So practice it. It's and like I said, this will be on YouTube. You can go through this thing, get your Photoshop going, and have fun with it.
Yeah, no, it's awesome. I like it. That nice little tool, because I've always taken my picture and said contrast or brightness or and then done the whole picture. It's like, wait, I don't want this part to be brightened. I want this part to be brightened. There you go. I mean, I don't have much knowledge in Photoshop at all, but just from the beginning, But that's great information. Thanks, Paul.
Yeah.
Awesome. Okay, let's go to quick what's up talk, and then we're going to do some photos, and then we're going to probably sign off. We have a little bit of an announcement to make at the end of the show, so we'll let you know that. So hang on for that. Okay, what's up this week? See what we got. Oh, here we go again, popping up on the wrong screen. Let's pull it up here. All right, let me do a share all first of all. And here. Okay, so of course we're going to take a look at what's up for the week. Just a few things to show. Of course, number one is the big launch tomorrow. Okay, so first of all, tomorrow at 11:33 a.m. ADT, we return to the moon. For those who have, those of us who love the moon, there's only one event happening tomorrow. Expected launch of Artemis 1 and our return finally to the moon. Launch time is scheduled for 11:30. Oh, it's 11:33. I thought it was 10:33 Atlantic time. There will be lots of live feeds, including those from NASA. I invite you to join me here on Facebook and YouTube if you like. And as I offer the live stream from NASA's feed, we can sit around and chat about it. And everybody shout hooray when it happens. Let's hope. Okay. So this is something that just popped up today. Just wanted to let people know that tonight there is a minor geomagnetic storm watch going on right now. It's a G1 level storm. For the ones who don't know what G1 means, it's the scale goes from 0 to 5, 0 being the least amount of storm and 5 being the largest amount of storm. So we're at a G1, which is just above the least, basically. But what's happened is that there was a CME, or a big chunk of plasma, that exited from the sun. It's on our way to us, and but coming behind it is this HSS, or high-speed solar stream, which is coming from a coronal hole, what they call, on the sun. So it's basically the sun has kind of stripped back one of the layers. All this energy is coming out in particles, and it's coming across as a solar stream, and it's coming behind the wave of plasma that's coming from the sun to CME. So it's kind of pushing it towards us. It's coming at a faster rate. So we're not sure exactly what's going to happen. It could be a G1. It might end up being a G2 later tonight, but just want to put it up there so that people that are in this area, so you can see there's G1, anything above that line. So we're talking very northern New Brunswick, across Ontario and Alberta. They get a better view, of course. So would I go out to see it tonight? From here, it's at a KP5. G1 might, if I had. But the good thing about tonight, though, is that there is no moon. So you have an opportunity to view this kind of a sky with no moon. Where I get my information mostly is from here, the NOAA.gov, which is the NOAA Space Weather Prediction Center. And this is their forecast. I took off this afternoon. So here we are, G1 levels. So that's from 6 o'clock to 9 o'clock universal time, which is 3 hours behind us, which is really 3 o'clock to 6 o'clock. That would be 6 to 9. This would be 9 till 12. So there it is overnight, basically, at a G1 level. So can it be a G1? Yes. Could it be a G2? Possible. You just don't know till the stuff arrives. So just wanted to put it out there that people are aware. If you happen to be looking north this evening and you're in a dark spot, take a few extra minutes, maybe take a look near the horizon, see if you see anything kind of funny along the northern horizon. If you do, get your camera out, take a 20-second exposure at ISO, say 1600 or whatever, just your cell phone, and see what you end up with. If you have anything that you'd like to share, then sure, send it in to us. We'd love to get it. Here's the predicted 3-hour KP, and this is from this is an app that I use called Aurora-Alerts, and it's a free app. For more data from this, you have to pay a couple of bucks, but I usually just look at a couple of days because they really can't tell what's happening in a week from now or 2 weeks from now. So this is the forecast for this evening. So again, from 3 o'clock right through till say 6 o'clock tomorrow morning, they're talking about a KP level of 5. So it's something to think about. If you're just looking north and you're out in a dark sky spot, and you're a little bit north of New Brunswick, then take a look. And again, if you see something kind of faintly along the horizon, get your camera out and take a picture. You'd be surprised at what a camera will capture where your eyes won't. Okay, going through the week though, Monday, of course, we've got the launch tomorrow, and then tomorrow evening, the moon greets Mercury. So look to the west on Monday evening, just after sunset, as the sky reveals a thin crescent moon, only 6% illuminated now. About 6 degrees, though, to the lower right of the moon sits little Mercury, way down here. Now just about 2 days after its greatest eastern elongation, or the farthest east in the sky it can be in the evening sky. Now, it might take binoculars to spot it, but you should be able to spot it by using the moon as a guide. Now be sure, of course, that the sun is already set as a safety measure before looking for Mercury, right? So that's one to pick out. Mercury's a little harder topic, or a little harder planet to pick out, because it only takes 88 days to go around the sun, and it's very rarely very much higher than this in our sky. So, but if you haven't seen it, it's kind of nice to see. One to scratch off your list. Wednesday, the moon and Spica are together. Wednesday evening, watch out for our crescent moon with Earthshine. Now, 20% illuminated, so that Earthshine is described as the dim glow on the darkened portion of the crescent moon caused by the light from Earth shining back on the night side of the moon. So this dull part that we see the whole moon here is really sunlight hitting the Earth, bouncing onto the moon, and then back to us again. Spica, of course, is a blue-white star about 260 light years away from Earth, and it's the 15th brightest star in a nighttime sky, and it's one of the major stars in Virgo, constellation of Virgo. From there, we're going to go to all week long. We have the planet Mars, near the Pleiades and the Hyades, which are two beautiful star clusters. Where are the constellations of winter, we ask? Well, they are in the morning sky right now. And if you missed your view of Orion lately, you can catch it if you're up early. All this week, the red planet Mars visits the beautiful Pleiades. We've seen that right up here. Looks kind of like a little tiny dipper. And the Hyades star clusters, which is this V shape right here, in Taurus. Now, nearby is the red giant star Aldebaran. Followed behind it, of course, is Orion with giant Betelgeuse, Rigel, and the Orion Nebula. And we got some people here got a block on YouTube. Okay. Let's go from here to next up after that. We've got all week long a great time to look at the Milky Way. As our moon enters its new cycle, of course, it sets in the early evening, which means that it's a great time to enjoy the wonders of the night sky. Now stare back at the center of our galaxy in the direction of Sagittarius, the teapot. This actually does look like a teapot if you follow it the right way. And follow from the horizon up through the star clouds of Sagittarius and through the wonders of Cygnus and the Summer Triangle and on through Cassiopeia. And simple binoculars will provide you with amazing views. Hey guys, just going up through here with binoculars.
Yeah. Yeah,
Beautiful
so
area.
much to see.
Okay, just give me a second here. I've just got to get rid of somebody. I got somebody joining us on through YouTube that is spamming me at the moment. Just another couple of seconds, please.
Yeah, that teapot, when you're looking at that, when you're looking at the southern sky, naked eye, that is so apparent. Like once you see it once,
Yeah.
You can't unsee it.
Yeah, that's right. Yeah, absolutely.
Like
Okay.
I said, it's in that area to look at in a pair of binoculars. It's just unbelievable.
Oh, so rich. Yeah.
Yeah, it's incredible to be looking at that part of the sky. There's the galactic center, of course, too, the center of our galaxy right there. And all through this large Sagittarius star cloud and up through the small, this is just amazing through binoculars. You really don't need a telescope to look at that part of the sky at all.
No.
From there, we're going to take a look at the ISS. We've got a few nice passes at the ISS this week here in our local area anyway. If you want to find out what it's like in your area, go to heavens-above.com. Look at the top right-hand corner. It asks for your location. Punch in your location. Update the page, and then click on ISS, and it'll show you the number of passes that it's going to make over your particular location. So here we are at minus 2.8, minus 2.5. The lower the number, in other words, the more minus the number is, the brighter the object is. So the ISS should be passing by. Minus 2.9 is almost as bright as Venus. Not quite, but almost as bright. So we've got a nice couple of passes tomorrow evening, and tomorrow morning, 4:21 and 5:54. These are all morning passes right now. You got to get up early for these ones, but they're worth it. I mean, if you happen to be out anyway going to work, or just happen to get up and can't sleep or whatever, great thing to watch. And the higher they are, usually the brighter they are as well. So, so a number of passes there. Just take a look at heavens-above.com, and it's always neat to see the ISS pass over. September the 3rd. Next week, we have a first quarter moon. Of course, on Saturday evening, our moon will be at first quarter phase, or 1/4 of the way through its lunar cycle. Now, this presents many wonderful features that the moon offers, like the mountain ranges that are right along here. You know, these beautiful mountain ranges here. We've got the large Maria, these large areas where the astronauts landed. And these are just large volcanic plains, basically. And you really don't need a telescope there either. Binoculars will give you an amazing view of the moon, for sure. Okay, so from there, I'm just going to talk about our little Fundy Stargaze coming up. That's next weekend. Hey, there we are. There's the gang from 2019. I guess that was, wasn't it?
That was our last time there.
Wow, yeah. So 3 years ago. So we're all really looking forward to this event coming up. Paul has the registration numbers. Apparently, there's quite a few that are registered for this event.
Yeah.
So this is us at Fundy National Park Stargaze in a place called Herring Cove, Fundy National Park. There's the space right there. That's what it looks like when you're there. So it's nice big field. The view this way is to the south. So we've got a little bit of hill out to the north, but nothing that really bothered our view. We were still able to get the planets and stuff pretty clear. And there's Comedy Central, our little stand for. We call it Comedy Central because we all get over here and start telling jokes and stuff. And
home away from home, yeah.
Home away from home, yeah. That's me with my gear over here on that side. I think I was getting set up there anyway. And here's a nice night sky view. So this is what you get to see looking out over the bay. There's the Pleiades. It's not right there. Yeah.
That would have been a little late, eh?
What's that?
That would have been a little later at night taking that
Yes,
shot.
yes, for sure.
Yeah.
Yeah,
Oh,
yeah. Pleiades coming up in the morning sky. So yeah, that's kind of like what we get to see for our sky. And there's our Milky Way shot. These are from Mike. These pictures. So
That's just the opposite direction.
yeah, opposite direction. So there's what we got. So that's a beautiful spot. I can't wait to get everybody out there and enjoy it. I'm gonna just take us quickly to this link. If I can load it, it should load. Maybe it won't while I'm open. Well, I got the file open. Might not. Just a second here. So I did. No, it didn't. Okay. If you go to that link anyway, rasknb.ca, you'll bring up the event itself and what it's all about. Click, control. No. Here we go. Hang on. Just trying to load here now.
Anyway, I can tell you what it's about.
Yes. Okay. Perfect.
So basically what it is, it's a 2-day astronomy weekend. We go up on Friday afternoon. We set up Friday afternoon. Friday at dusk, we will have a projection screen and we'll do a talk on what's up in the sky and talk about astronomy. And then from there, usually around 9 o'clock or short thereabouts, it starts to get dark, and then everybody mans a telescope, and then we just observe. We have a good time. And we do that through to about 11:30 or so for the public, and then us crazy people stay up all night and have a blast. And then we go to sleep. Then we get up early in the morning and drive down and have breakfast. That's not part of your curriculum. I just want to tell you what we do. And then we come back up, and then on Saturday from 11 to 3, we have solar observing. So if it's a sunny day, we're going to have special telescopes that you can look at the sun. And if you have a telescope of your own and you want to use it that night and you're not sure how to work it, bring it on over. And there's a whole bunch of us that would be happy to help you with your telescope. And that's what we'll do on Saturday afternoon. And then Saturday night is a repeat of Friday night. So again, around 8:30 or so, we'll do our talk. And then 9 o'clock, we hit the scopes. And again, we have another absolutely wonderful night of observing. Awesome. So that's what the weekend is. If you want to attend and you don't want to camp for the weekend, you can come in and attend the thing. I think there's a park fee you might have to pay to get in for the day. But other than that, you are good to go. And you can leave whenever you like. They don't put locks on any of the areas, so you can come and go as you need, depending on what time you want to stay till. That's not an issue. I had a long chat with the park about all of those things for those who don't want to stay. For those who do want to stay, well, they're sold out. So if you haven't got a space to camp, you might not get one. So
right. Oh, they're sold out, are they already?
Yeah.
Oh well, awesome. Yeah. See, they do every year. They sell out for this.
Well, it's a Labor Day.
Labor Day weekend too. Not necessarily. Yes. Yeah. So here's a little bit of a zoom into where we are. So we're not actually in this part of the park. Like this is where the headquarters is, and down around the pool, and come down past the golf course. So you go by the golf course, down the road quite a ways. But then there'll be signs up here telling you where to turn. You're going to turn in to the left, follow up through Herring Cove, right there, and there's where we are located, right there.
Yep.
So so here's your parking area, which is great because you park over here and walk in, and that means that our skies stay dark in here for us, so we can show you more stuff. So no headlights are hitting us. That's always great that way. So we're really looking forward to it. You know.
By the way, Chris, the park will have a setup right where you park your car, and they will guide you down, and they'll talk to you a little bit about what's going on in the area. Awesome. So there's going to be somebody there to help with that part of us. You don't come in blindly. There's going to be somebody there to help you get out of your car and get down to the field.
Awesome.
Perfect.
Okay. Okay, that's what we're going to be looking at. Let me see if I can get back to my slideshow. Maybe I can, maybe I can't. I'm going to stop presenting and have to go back into presenting again. I've only got a couple of more slides, so hang on. Okay, so can I get back to this? I think I can. Slideshow from current slide. Okay, let me go back through here. And I might have been pretty close to the end anyway. I was pretty close. Anyway, so we want to go to Lisa's Lookup. Lisa Ann Fanning on here. Lisa has a Facebook page called Lisa's Lookup, Astronomy and More. It's a fantastic page. You want to learn more about astronomy, go see Lisa's page, sign up there, or just click a like and you'll get to follow. Lisa puts up this chart every month. I refer to it all the time. Here's where I got my first quarter moon information. And she puts up this great chart all of the events that are happening now. This is through the month of September, of course. The dates that are going to happen, the peak times to watch those events. Say it's a meteor shower, maybe the best time to watch it. And then seeing tools. Can you do it with naked eyes? Do you need binoculars or a telescope? So list everything down here, what's required. So you can find her at Ruby Moonbeams on Instagram, Facebook, and Twitter. Always look forward to that, Lisa. Thanks again. And of course, our August-September calendar. We're in this coming up to September now. So here's our events coming up for the next couple of weeks across here, including our Fundy Star Party. This is put up by Kurt Nason, which is our veteran astronomer here in New Brunswick. Member of the St. John Astronomy Club and the Royal Astronomical Society of Canada, the New Brunswick chapter as well. So we thank Kurt for that every month, bringing that information to us. And from there, that's about all we got to say about this week coming up.
Put on some pants.
Yeah.
Okay. There you go.
Okay, now let's get quickly to some photos because I got a few photos to share. Just need to get my notes up and going here first of all. Here's my notes, and now I got to get my photos open. Remember, we do love getting your photos. You can send them into SNAS at astronomybythebay.ca or SundayNightAstronomyShow@gmail.com. And let's see what we got this week for photos. Okay, so we're going to start off with Matthew Dupre here. Matthew sent in these other captures of his submissions for the week. I took full advantage of Saturday night, he said, to the morning first image. The first image is Milky Way. We'll get to that in a second. He took 20 minutes. Also, last night he set up and got lucky with Jupiter again and got lots of data in this image.
Lucky, yeah. Nice shot.
That's unbelievable.
Yeah, it's incredible what he's capturing there. He had derotated and stacked 4 images of the planet in Winjupos, whatever that is.
Yeah.
Okay.
Winjupos,
each and taken 5 minutes apart. Doing this increased the sharpness and detail a lot. That's amazing image. That's top quality, Matthew. Well done.
Well done.
Now, here's his Milky Way capture as well.
That's another one well done.
Yeah.
It's the first images of the Milky Way. I drove about 20 minutes out of Miramichi to a Bortle 2 sky and took 20 minutes of exposure. So well done, Matthew. Thanks for those. Great to have you on board sending in photos. We really appreciate it. Now, these ones come from Duckman. Duckman R. Snow, regular contributor here as well. He said, I started playing with my manual mode on my Nikon P9000 and was able to get better pictures of Saturn. Might get better if I keep playing with it. He said, taken on August 22nd at 1 a.m. So, I mean, with a camera.
So, make up the rings there, yeah. That's all.
Pretty good for a camera.
Not bad at all.
Thanks, Duckman, for those. Got this one from a new contributor, Raymond Kwong. He says, there are some obvious flaws, but contributing the North American Nebula and Deneb. There we go.
Where's that at? Where's that? What area?
I'm trying to. I emailed him to ask him what part of the sky it is, but I can't really find out. My neck hurts when I look up that high. That's the problem.
Nice capture, though.
There you go. Nice one. Thanks, Raymond, for that. Well done. Yep. And Deneb's there, nice and bright. Perfect. Okay, from there we're going to go to Kathy Adams. Kathy said, hi, I meant to send this earlier, but I was able to capture Io transiting Jupiter.
Oh, beautiful. Yeah, there it is.
Despite not so great skies. I captured it with my Celestron C5 spotting scope. Like, great stuff for a C5. And ZWO224 planetary camera on my Skywatcher AZ GTE mount. Hopefully dry, clear nights are coming. I'm sure they are, Kathy.
Keeping our fingers crossed.
You bet. Especially next weekend.
Nice shot.
Yeah, beautiful. And I got this one from Brad. Actually, this was sent in last week. I apologize to Brad for not having it up last week, but I missed it. He says, hi, Chris. Here's a shot I got of the Perseus and Pleiades reaching the sky over Grand Lake last night. Or maybe I did show this one last week. I can't remember.
No, I didn't see it.
Okay. I had a friend ask if I could capture a photo of the moon on her wedding night, and I grabbed this shot while I was waiting for the moon to rise.
There you go. Nice shot.
Yeah.
Really?
I also just noticed that Mars is hiding down in the bottom right there.
Yeah.
Good stuff. Yeah, so that's now up around the Pleiades Hyades this week, right?
It is.
Good time to pick it out. Awesome. Thanks for that, Brad.
Mm-hmm.
Very nice. And we're going to move on to Jason Dane here.
Oh,
Jason,
yeah. Beautiful shot.
Yeah. He says, now this region of bright and dark nebula is located in the constellation of Cepheus. It sits just over 11 degrees from Polaris, and the objects are cataloged as LDN 1228, LBN 552, and LBN 550 respectively. Now, near the center of LBN 552 sits an Orion or Orange Reflection Nebula, cataloged as Cohen 129, which appears as a triangle protruding from the dimmer diffuse nebula region. This is the second image from my new Skywatcher Esprit 120 and my first LRGB image with it. So I made a goof on this one, imaging 2 nights with the wrong rotation before I realized now dark nebula are tricky to compose. You bet, yeah, as you often cannot see the structure in a single sub-exposure. It is only after several hours of integration time that the structures start to show. I enjoy the challenge of shooting these obscure, dark, and dusty regions, and this one delivered for sure.
Yeah,
It sure did.
Yeah, integration time was 18 hours with 180 subs at gain 120. A telescope was a Skywatcher Esprit 120 ED, Apple. Imaging camera was a ZWO ASI 294, guiding with a Starfield 50mm guide scope. Optolong LRGB filters, Skywatcher EQ6R Pro mount, flats and dark flats, ASI Air Pro, Pegasus Power Box, ZWO EAF and EFW. Processing was done in PixInsight. So amazing.
Man.
Yeah.
The dark nebula are really fantastic.
Oh, it's just
yeah.
incredible shot.
Yeah. He likes to shoot stuff that's different.
Yeah.
And he's got a lot of very cool dark nebula stuff going on.
Yeah. Really interesting.
Yeah.
Okay, going to pop over now to Chris Benoit from today's Sun. Nice big
Yes,
sunspots
very
here.
nice.
So
Thanks,
yeah,
lots. Activity.
yeah.
This stuff's really nice. Yeah.
Here comes again. Yeah. So that might be part of the. That's not part of the discussion tonight. I think it's this one down here that caused the aurora tonight, or what might lead to aurora anyway. And then finally we got Ian Bloom here. Hi guys, he said it's been a few weeks since I submitted any photos. Ian's of course from down under. The skies have been very unkind to us here down under, so here's an image taken earlier this year of the Flame Nebula and the Horsehead Nebula.
Yes, sir.
Imaged with my stock 700D Canon, coupled to my 115 Sky Rover triplet refractor. Awesome.
Very nice.
Thanks for that, Ian. Appreciate that. Nice
Down
to see the
under.
sky.
Wow.
Down under, yeah. Cool. Hey, where's this one from? Let me see.
Good shine. Beautiful.
Mr.
I
Mike
couldn't
Powell.
resist it. I ducked under the trees to get that shot, and I forgot my tripod, so that's a handheld.
That's pretty
nice
good for
shot.
handheld. Beautiful. Yeah.
Wow.
Taking a 438, you said this morning was a couple of days ago, handheld with Canon 60D at 400mm image stabilized. On this day, the moon was 27.57 days old, 3.53% illuminated.
3%. Yeah.
That's
Awesome.
awesome. You really
I
got
I went to get the tripod to come back and take the shot. The cloud rolled right in front of it. I didn't have time. So
Good. It knew you were coming back. Yeah, of course. They
it
better
was
stay
such a
away.
nice one to look at, though. That was real pretty.
Great shot. Yeah.
Thank you.
And then we get this one.
There you go.
Mr. Owen. Okay,
Yeah.
Paul says this is a work in progress. He said the Pinwheel Galaxy is a face-on spiral galaxy, 21 million light years away from Earth in the constellation of Ursa Major. It was discovered by Pierre Méchain in 1781 and was communicated that year to Charles Messier, who verified its position for inclusion in the Messier catalog as one of its final entries. The scope used was Skywatcher Equinox 120, reduced f6.5, camera ASI 2600mm mono with ZWO electronic filter wheel, Optolong RGB 36mm filters, Skywatcher EQ6 Pro mount, or Orion SSAG with 50mm Skywatcher guide scope. Where's all this? Like, I just talk about a smartphone. Acquisition software, SGP, stacked and processed in PixInsight, exposures, RGB at 24 at 180 seconds, flats and darks applied, waiting for clear skies to grab the hydrogen. That was before, so you've already got that, I guess, Paul, eh? So, yeah, now we're into the hydrogen. And,
hydrogen.
Yeah, so these are the star birth areas where the stars, as they go around, as that galaxy spins around, you can appreciate that the stars in here kind of slow down and the ones out here are going faster, so they kind of bunch up like a traffic jam on a highway. And then when they compress or they all come together in an area, then we have starbirth, and that's what all these darker red areas are, right? So, yeah.
What really impressed me at your shot there, Paul, if you scroll out, Chris.
Yeah.
Go up to the top, and you'll see part of the galaxy up there.
Over here.
No, down a bit. Right. Scroll in and into that area a little bit. Oh, there it is, right up the very top, way up.
Way up. Okay.
Lower down.
Picture. That
There,
one?
up there. The
okay.
detail you've got up in that little corner is amazing.
Yeah.
Like that's another piece of that galaxy out there, I think.
Yeah.
It's not a separate galaxy. I think it's still a cloud off of that one. But man,
I was wondering if that was part of it or not. I didn't research that, so.
I think it is. When you scroll back out, you can kind of see. I think it's part of an arm.
Leading up that way, yeah.
Yeah.
Right
but
here.
man, I looked at that and went, wow, the detail in that little corner. Like the rest of it is, it's just jaw dropping. But that blew me away. What you got up there in that detail in that little spot.
Yeah, it's amazing. What a capture, amazing capture, Paul.
Thanks.
Yep. Lots of detail. Okay, so let's go from there then. I think that's what we got tonight. So if you have some photos that you'd like to share, we'd love to get them. Send them into Sunday Night Astronomy Show at gmail.com or SNAS, S-N-A-S for Sunday Night Astronomy Show at astronomybythebay.ca. And we'd be very happy to get your photos and very happy to put them up on our next program, which is what we're going to talk about here next. So just going to get to my closing notes. And I'll stop my sharing here, stop presenting. Okay, so just a note, let me get this back to full screen. So just a note to say, first of all, that we are going to be taking the next couple of weeks off from the program to enjoy a little bit of the summer. Next week, of course, we're all at Fundy Star Party event, hoping for clear skies down there. So by the time, when you get Friday and Saturday night in down there, you're not going to bed till 4 or 5 o'clock in the morning. So usually we wait till Orion pops up. So it's usually 6 o'clock. We get a couple hours sleep and you're exhausted from the night before, and then we have 2 nights in a row. So by the time Sunday comes, we're not ready to do another show. So we figure we'll add up our outreach event for that for next week, and the following week I'm actually on vacation, so we won't be contributing. So we won't be back until the 18th of September. So that's when we'll be returning for our next program. So we hope you'll all join us then. So in closing then tonight, we thank you once again for your continued support of our efforts here. Our special thanks once again to Rosanna, of course, for her contributions to the program. Thank you, Rosanna. We really do appreciate it every week. We also hope that those of you who have joined us from Rogers enjoyed the program here. If you would like more information about the wonders of the night sky, you can find me at astronomybythebay.ca. Also, special thanks to those of you who share our program, Trudy, our friend Trudy, Sean at NB Storm Weather Center, many more, Brad and everybody. We really do appreciate your sharing it as well. Remember, we do love getting your photos, so send them into SNAS at astronomybythebay.ca or Sunday Night Astronomy Show at gmail.com, and we'll be happy to include them on our next broadcast. Now, if you have suggestions for topics for future shows, please send them in too. We always like getting your ideas. We want to put that information back out to you again, so give us your ideas. And please let your friends and family know too that we will be back here on Sunday, September the 18th at 8 p.m. Atlanta time. Hey.
Pictures.
What's that?
With lots of pictures from Fundy.
Lots of pictures from Fundy. Let's hope. Yeah. Even if it's cloudy skies, we'll get pictures of the clouds. We don't care. We'll be here at 8 p.m. on YouTube and Facebook on September 18th to edutain you on astronomy and the wonders of the night sky. So for now then, from Mike and Paul and I, we wish you a safe and happy couple of weeks, everybody. Remember, tomorrow morning I'll be tuning in to the Artemis launch, and if you'd like to join me on YouTube or Facebook, I would love to have you on. So for now then, have a great couple of weeks, lots and lots of clear skies, and we like to say, guys, open your eyes to view the skies and keep your scopes pointed up. Good night, everyone. Thank you for joining us.
Mr. Music, please.
There he is. Night, everyone.